We're going to learn something called rationalizing the denominator. And you do this when the number under the radical sign in the denominator's place is not a perfect square, it's not one of these numbers, you have to rationalize the denominator. And that's when you manipulate the problem to create a perfect square. Well, the way you do this is you multiply by the denominator over the denominator, like this. There's the denominator, I put it over itself, and really all I've done is created a 1, and when I multiply something by 1, it doesn't change its value, so that makes it okay. It does change the numerator though. The numerator will be 5 times 3, which is 15n, and the denominator is the square root of 9n squared. I created a perfect square there. So 15n will not break down, so he stays up under the radical, and then the square root of 9n squared is, the square root of 9 is 3, and remember the square cancels the square root out, so the n is out from under the radical as well. So let's do this again. With 1 over root 5, I will multiply by root 5 over root 5, which is just the value of 1. So the numerator becomes 1 times root 5, which is root 5. The denominator becomes root 25, which turns right back into a 5. If you want to skip this particular step, you can. You cannot reduce 5 in the 5 under the radical and the 5 that's not under a radical because of the radical. All right, here we have another one. We're going to multiply by the root 3 over root 3, which is 1. So in the numerator, I have 10 times 3, which is 30. And I can't think of any perfect squares here that would go into 30 evenly. So that's already simplified. And the square root of 3 times the square root of 3 is the square root of 9, which turns right back down to a 3. You cannot do anything else with that one. All right, so here we got to multiply by the square root of 2x over the square root of 2x. I have 7 root 2x. The 7 is not under the radical, so it's just going to be on the outside here. And then 2 times 2 is 4, and x times x is x squared, so this turns right back to a 2x. There's nothing else to do to that problem. Okay, and then for the last one, they've written it all up under there, so you can separate it if you need to, like so. Then multiply by the root 3 over the root 3. 2 times 3 is 6, so I have 6y squared. The y squared can cancel out, but the 6 is going to have to stay up under the radical. And then 3 times 3 is 9, so the square root of 9 is 3. Okay, so y squared can come out from under the radical because the square cancels the square root. The 6 will stay up under it, and then we have the 3 in the denominator.